So now we're going to start multiplying polynomials, and again, this is something that you're familiar with already. Remember back in semester 1 when we were multiplying something like x plus 3 times x plus 2, and we would FOIL and multiply to get a quadratic expression. So it's really the same thing when we're multiplying polynomials, except it's a little bit longer. So instead of FOILing, which is just distributing, we're just going to distribute one more time, because FOILing only works for when you have two terms times two terms. So in here we have x plus 4 plus 2 times 2x plus 3y minus 5. And normally what we would do is we would start with the x, and we would distribute it and multiply it to the 2x, right? Because I'm multiplying. So I have to multiply the x to the 2x and the 3y. And because we have an extra term, there's 3 terms in this polynomial, we're just going to multiply the x one more time, that's all. So 1x times 2x is 2x squared. X times 3y is 3xy, or 3yx is not wrong, but we try to write it in alphabetical order if there's more than one variable in a term. X times negative 5, negative 5x. And then we're going to do the same thing to the 4. So multiply that to the 2x, the 3y, and the negative 5, really distributing 3 times. So 4 times 2 is 8, 8x, plus 4 times 3y is 12y, 4 times negative 5 is negative 20, and then once we multiply, we try to combine like terms when we can. So 2x squared, nothing to combine, 3xy cannot combine, but this negative 5x and the positive ax I'm going to combine to make positive 3x. And then 12y can't combine with anything, and negative 20 cannot combine with anything. So we end up with a very long polynomial, which is okay. So once you multiply every term, you're going to try to combine like terms and simplify if you can. And sometimes the end, your answer is still going to be quite long, which is all right. So that's really pretty much the same thing as what we did when we multiply binomials. I'm going to show you another way to multiply that might be easier, just another way to look at it, and it's entirely up to you when you do your practice which method you want to use. Now for this method, we're going to draw a grid, and because I have a binomial 2 terms multiplied by a trinomial 3 terms, I'm going to draw a 2 by 3 grid with 2 rows and 3 columns. And I'm going to cut this up into rectangles. Okay, and then I'm going to write x plus 4. You could put plus, or usually if we don't put a sign, we assume that's positive. And then across, we're going to have 2x plus 3y minus 5. And all we're going to do is we're going to multiply and find the area of each rectangle. So the top left box in the first row, first column, we're going to get by multiplying the x and the 2x. So the x and the 2x. Okay, so 2 times 1 is 2, x times x is x squared. And then in the next box, we're going to multiply the x times 3y, which is 3xy. And then negative 5 times x is negative 5x. And then in the second row, we're going to multiply the 4 by the 2x. So that's going to give me 8x. 4 times 3y is 12y. And 4 times negative 5 is negative 20. So once you multiply and fill in each box, then you're going to write it out. And we're going to try to write it in standard form. So highest degree first, I'm going to start with the 2x squared. So 2x squared, cannot combine that with anything. Plus 3xy, also cannot combine. But then I see that I have like terms here, negative 5x and 8x, which is going to give me 3x plus 12y minus 20, and we get the exact same thing. So whichever method you like better, sometimes if the polynomials are really long and the signs can get a little confusing when you're distributing, it might be easier to draw out the grid and do the area model. So let's try another one. This one is even longer. We've got a trinomial times a trinomial. So I'm going to do the area model for this. And if you like distributing horizontally, you can do that as well. Should get the exact same terms. It's just not going to be in a box, that's all. So because I have 3 terms times 3 terms, I'm going to divide my grid up into a 3 by 3 rectangle. And I'm going to have 3y squared and 6y and negative 1. And then across I'm going to have 4y squared, negative 11y, and negative 5. And then I'm going to multiply just like before. So first row, first column. 3 times 4 is 12. Y squared times y squared is y to the 4th. Remember when we multiply exponents of the same base, we add their exponents. And then going across, 3y squared times negative 11y. So 3 times negative 11, negative 33. Y squared times y is y cubed. And then keep going. 3 times negative 5 is negative 15 y squared. Second row, 6 times 4, 24. Y times y squared is y cubed. 6 times negative 11 is negative 66. Y times y is y squared. And then negative 5 times 6 is negative 30 y. And then last row, you're going to multiply everything by negative 1. So just changing all the signs. Negative 4y squared, positive 11y, and positive 5. Okay. So once we multiply every single term, again, we're going to write it in order and write it out. And then see if we can combine any like terms there. So I've got 12 y to the 4th, which there's no like terms to combine, but then I have negative 33 y cubed and positive 24 y cubed. So that's going to give me negative 9 y cubed. And then I have negative 15 y squared, negative 66 y squared, and negative 4 y squared that I can combine. So that's going to give me negative 85 y squared. And then from there, I also have negative 30y and positive 11y that I can combine to give me negative 19y. And then finally, I have my constant, positive 5, that I can't combine with anything. So that's your polynomial after we multiply. 12y to the 4th minus 9y cubed minus 85y squared minus 19y plus 5. And same thing if you want to multiply horizontally, you would just have to distribute your 3y squared to each term. Okay, and then distribute the 6y to each term. And then finally, one last time, distribute the negative 1 to each term, and be careful with your positive negatives, and then combine like terms. One last one. You've got the quantity 2a minus b raised to the 3rd power, and remember when we were raising things to the 2nd power, we said we can't distribute this exponent in this corner if there is a plus or minus in my expression. Okay, so I can't distribute it. This is not 2a to the 3rd power minus b to the 3rd power, not it. What we have to do is we have to write it out. So this is really just, you've got 3 of them. You've got 2a minus b times another 2a minus b times another 2a minus b. You're raising it to the 3rd power, multiplying it by itself 3 times. And so when you've got 3 things that you got to multiply, think about multiplication. Remember, multiplication is commutative. That means if I have 3 times 4 times 5, I could do 3 times 4 first and then times 5, okay? Or I could do 4 times 5 first and then times 3. It doesn't matter. You just multiply any 2 of them first and then multiply by the 3rd, all right? So I'm going to go ahead and just ignore one of them and multiply these two first. I'm going to keep that one in the front for later. I'll worry about that later. And I'm just going to multiply these first, okay? And because it's not super long, I'm just going to do my distributing horizontally. If you want to do the area model, you can. So 2a times 2a, so that's going to give me 4a squared. 2a times negative b, so that's minus the negative 2ab. And then I'm going to multiply the negative b through. So that's going to give me negative 2ab again, and then positive b squared. Negative b times negative b is positive b squared. And notice that these do not cancel out. They are not opposites, but I can combine like terms. So I'm going to keep this that I haven't touched in the front, 2a minus b. And then I'm going to rewrite these. So 4a squared, and then negative 2ab minus another 2ab is negative 4ab plus b squared. Okay, and once I multiply two of them, now I can keep multiplying. So I'm going to do the exact same thing. 2a times 4a squared, 2a times 4ab, 2a times b squared. And again, if you want to do the area model, you can draw out a 2 by 3 grid. Okay, so 2 times 4 is 8. A times a squared is a cubed. 2 times 4 is again 8, but it is negative in this case. A times ab is a squared times b. And then 2a times b squared is positive 2ab squared. And then I'm going to multiply the negative b to each term. So that's going to be negative 4a squared b. And then negative times negative, the next term will be positive 4ab squared. And then negative b cubed. Okay, so then from there, let's see if we can combine like terms at all. Looks like 8a cubed is all by itself, so nothing to combine there. Negative 8a squared b, I have another a squared b that I can combine. So here's one, and then here's another. So negative 8 minus 4 is going to give me negative 12 a squared b. And then we've got positive ab squared and positive 4ab squared. That's going to give me 6ab squared. And then finally we've got this negative b cubed that I can't combine with anything. So 8a cubed minus 12a squared b plus 6ab squared minus b cubed. When you've got three things that you're going to multiply any two of them first and tally up to you which one, and then multiply it to the third.